What's Jabelin's Jables?
Not sure what that means, but what's going on? Here we are doing module 13, practice problem number 6, which Martin is going to read to us now.
What is the sign of entropy for the following reactions? They're on the board. I'm not reading all those out.
So the sign will either be positive or negative. Okay. Entropy, you can think of as disorder, right? So, what's that?
Chaos.
Sure, chaos. So what will happen in the change in entropy? We're looking at the difference between the product side and the reactant side, right? Mm-hmm. So we're going to be subtracting the entropy, right, of the reactant side minus the entropy of the product's side in order to calculate it. But we're not asked to calculate it here. We're just asked to give the sign. How are we going to be able to figure that out?
Well,
we have to apply the principles that they give us, the general principles.
Yeah.
Right. And what are the general principles?
If we have a gas that's the highest entropy.
Right. So again, this is a state function, right? Entropy is a state function. So we're going to look at the states of our matter in our chemical equation. So here we have aqueous and aqueous. Those are both dissolved solids. That's what that means, that they're aqueous, right? And solids have the lowest entropy, right?
Yep.
Gases have a higher entropy, okay? And liquids have a higher entropy than solids. Gases have the highest entropy. So we can see that our product side has gas and liquid.
Yes.
So that tells us that the entropy is greater over here, which means that this is going to be a positive. So letter A is positive, okay? How about B? We have this HCl, which is a gas, and NH4, which is ammonium hydroxide, which is a gas, and ammonium chloride, which is a solid, and liquid water. So which side has greater entropy?
The reactants.
The reactants side. So this is going to be a negative delta S.
Negatory.
Okay, how about letter C? Tricky. So here we have sulfur dioxide gas and what's this? Fluorine, whatever, fluorine.
Yeah.
And it's a gas, and then we have sulfur hexafluorine or whatever it is, and oxygen. So they're all gases. So what's the next rule that we're going to apply? We're going to look at the number of molecules of each, because whichever has more molecules of gas is going to have more entropy than the other side, okay? Since they're all gases. So if we look at this, how many molecules of this do we have?
1.
1 and 3 and 1 and 1. So
it's negative.
Yeah, this side has more entropy, so it's going to be a negative sign. Okay? And that is it for number 6. And we're going to do another video.
Catch you on the flip-flop, Jables.
Well, not necessarily the flip-flop,
Yes,
but on
the
number
flip-flop.
7. Number 7.